Okay, peace and blessings. It's your brother Sorry back with yet another one. Peace to the true and living. Who is the true and living? If you are watching this, if you've been locked in, you know what I'm saying, for the from the simplest to the more complex, you know what I mean, you are the true and living. It's a pleasure to make your acquaintance. um, yeah, back with another one. We're gonna kind of continue on this same tangent that we've been kind of going on. Um, with this one, um, we're going to continue down the road, the rabbit hole of, cellular biology, human cellular regeneration, human photosynthesis, that whole conversation right there. Um, on a previous video, we went into the work of Albert Szent-Györgyi, as well as that's the individual, that's the first individual to in modern times to state that mitochondria functions like a semiconductor. Proteins behave like semiconductors and things of that nature. So that's one of the pioneers of this whole thought process that the body is electrical. You see what I'm saying? The person that continued his work is um, Robert O. Becker, and that's the person who perfected the process to regenerate human limbs and things or what have you. So, in a previous video, we read a section out of Dr. Jerry Tennett's book, Healing is Voltage, a little section about some of Becker's experiments with salamanders and all that. Okay, so in keeping with this same kind of current that we've been going through, now, in previous videos, you know, kind of how we do on this channel and with some of this material and everything like that. We deal a lot with the idea of the ether, or there's a whole playlist that's dealing with the ether and everything like that. And when we talk about the ether, we anchor that idea in 19th century pre-electron etheric physics, like similar to that of Tesla and Eric Dollar of this day and time, um, John Keeley, Oliver Heaviside, people like that before J.J. Thompson invented the electron. You have more Einsteinian physics. Now, the language that we talked about on the previous video, when we were talking about proteins exchanging electrons, you might have to bring your attention span to this video. Proteins exchanging electrons and producing ATP and all this good stuff like that. Getting kind of sciencey on this others to self stuff, but it kind of paints a decent picture, what have you. They're talking from that perspective, and as we showed on a couple of other videos, sometimes it on the video. The nook to the smallest particles, the black dot, and everything like that. We showed that when you filter some of these concepts and some of this stuff through multiple different people's frameworks, you get these little interesting nuances and things. So, in keeping with that whole thing, what we've been doing on several other videos, um, if Tesla don't believe in electrons, right? So Tesla didn't deal with electrons. So when we talk about proteins exchanging electrons and opening up, creating holes so they can bond with other, exchange electrons with other proteins and everything like that, or what have you, mitochondria, you see what I'm saying? Like how we talked about the melanin dissociating the water and everything like that, or whatever the case may be. And it's a lot of talk of electrons or what have you, but we must remember that Tesla didn't deal with electrons. Remember how we did in the video when we talked about CERN and everything, the Large Hadron Collider. But Tesla don't believe in hadrons. So what were they really doing? In that video, we run into something where um, they're creating perturbations or disturbances within the ether, a disturbance within the force loop. You see what I'm saying? So it sounds kind of like that. So we filter things through different frameworks. Sometimes we get, I don't know, a straighter picture. So, yeah, we're going to go in here and, as usual, using the AI for good and not evil. We're going to go in here and kind of cross-reference some of this. Now, if you've been watching any of these videos on any of this type of stuff, you probably know who Eric Dollar is. You probably know who Nikola Tesla is. Whenever I um, try to get a glimpse into the mind of Nikola Tesla, it's a lot of crazy stuff on the internet. I always balance it out with the perspective of Eric Dollar because he's a living person right now that's probably the most knowledgeable on the recreation of Tesla's experiments. So things that he may have posted or his framework for how he deals with electricity and electrical phenomena is very similar to the mindset of Nikola Tesla. And I would encourage anybody who's trying to follow the research of Nikola Tesla to include the lectures, writings, whatever have you, of Eric Dollard in there to kind of keep you on the right track. Okay, so we're gonna go into this. Let's see here. Okay, so so this is just a hypothetical thing or whatever. We're filtering this stuff through a different framework. So just a little bit. Let's see. The conceptual foundation led Tesla to a distinct. Gonna give you a little bit about Tesla, and then we're gonna go down and get to the punchline of this as we always do. Okay, this conceptual foundation led Tesla to a distinct understanding of energy. He's talking about the Vedic metaphysics and everything like that. And its transmission, he made a clear distinction between what he termed radiant energy and more conventional Hertzian waves. We've talked about that before. We used the circle of space and matter time to kind of illustrate that in an abstract kind of way, described by Maxwell's equations, while Hertzian waves are transverse, propagating in all directions, and diminishing in accordance with universal square law. Tesla's system of wireless transmission relied on a resonant action across lines of rays of electric induction. So these resonant action, when we get into proteins exchanging electrons, the idea of resonance is going to come back. Okay, so let's see here. Crucially, this is really what I wanted to get into. Crucially, Tesla's framework for electricity did not require the electron as a discrete particle. So back to that's one of the main punchlines why we even kind of going over this preemptively. Um, he explicitly disagreed with the idea of atoms being composed of smaller subatomic particles, asserting that if electrons existed at all, they were a fourth state of matter, or more accurately, a manifestation of the ether itself. For Tesla, the physical and energetic phenomena of electricity were not a result of particles moving, but rather of the ether being manipulated. He suggested that static electricity was an effect of ether under strain. Remember, we were talking about some of the main concepts. You have to go back into some of those other videos on the in the ether series where we kind of get into that, where he talks about magnetism, that's the ether in motion. Electricity is a polarization of the ether. Dielectricity, as he calls it, is the ether under stress or strain. Various different, we go as we go through the lingo. Okay, so as we go through the lingo of that framework, rather. And dynamic electricity was an effect of the ether in motion. This view fundamentally challenges the modern understanding of charge transfer in electrical current. So substituting the mechanical fluid model for a particular one. Okay, so let's see here. Mm, Trying to make sure I'm not missing anything. Okay. Okay, it talks a little bit about Eric Dollard's perspective on electricity. Um, his is very similar to that of Tesla's, so just not to kind of bog it down, because if you keep going on some of the Ether series, I, we go into his perspective somewhat. Okay, so Albert Szent-Györgyi, the electronic dimension of life. Albert Szent-Györgyi, Nobel laureate in biochemistry, embarked on a profound intellectual shift in his later years, moving from the study of molecular processes to the exploration of bioelectronics. Right? We have a whole video on this, the previous video that was done. Human photosynthesis part two. His dissatisfaction stemmed from the realization that the slow molecular level interactions of biochemistry could not adequately explain the rapid, highly organized processes of life, such as muscle contractions. He advocated for an extension of biology into the submolecular and supramolecular dimensions, a realm where electron transfer, rather than simple chemical reactions, govern cellular processes and regulation. So he's one of the guys who came up with the whole body being electric or whatever. The body is electrical or whatever. But you notice he's using the language of electrons. He's talking like that or whatever case may be, which is different than Tesla's framework. So that's going to be the contrast in the conversation later. Let's see here. At the heart of his theory was the audacious hypothesis that biological macromolecules, specifically proteins, could act as semiconductors, right? He posited that delocalized electrons, remember, could be excited into conduction bands, creating mobile charge carriers and movable holes, so that charge from other proteins can come in within the molecular structure. This mechanism, he argued, was fast enough to account for the speed of life's processes. According to Szent-Györgyi, life itself is driven by energy released when an electron moves from a higher energy level to a low one, right? He even proposed that the emergence of life on Earth was contingent upon the presence of oxygen, which he saw as the first electron acceptor, desaturating the conduction bands for primitive proteins and thereby increasing that where they're losing the electron as he's describing and making a hole so that another electron can fill it. He's saying oxygen has that capacity. Okay, thereby increasing their electrical conductivity. The semiconductor model is a powerful conceptual bridge in St. George's work, connecting the macro scale of living organisms to the micro scale of electronic physics. It moves beyond a purely classical biochemical model, which relies on molecular diffusion and random collisions, toward a physics based, field like model of communication. So throughout the whole Ether series, we've been talking a lot about fields and stuff like that. The field theory, fields, all that stuff like that. Like I said, on the high side, we were talking about morphogenic fields, kind of bringing it back down to the human biology in the cell and all that stuff like that. So toward a physics-based, field-like model of communication between cells and everything like that. The semiconductor, a physical structure which conductivity can be modulated by external fields. A semiconductor, cells are semiconductors, mitochondrial cells are properties of semiconductors, human body, carbon-based semiconductor, but that semiconductor can be manipulated by external fields, like non-native fields, so to speak, as we've been seeing in certain research we've been doing. Okay, so this framework reframes the body not merely as a collection of chemicals, not merely as a collection of chemicals, hormones, and all that. Chemicals such as hormones, enzymes, you know what I'm saying, all these different things, but as an organized dynamic system of interconnected semiconducting circuits, right? Okay, so, and keep in mind, he's talking about electrons. He's talking when he's in the how he explains it or whatever case may be. It suggests that the body's energy and communication networks are physical systems governed by electronic principles, a perspective that provides a critical starting point for the cross-referencing with Tesla's non-particulate electrical system. So that's going to be the punchline of this whole video, where we're explaining his research, skimming over it enough so you can I explained it a little bit better in the previous video. I mean, but he has you know, you can go on the internet, you can, you know, peruse certain information and see what he's all about or whatever. Go down that rabbit hole yourself or whatever case may be. But the punchline is Tesla's non-particulate electrical framework that we want to filter this through to kind of see if we get some different nuances in this. At least according to the AI, it ain't like we digging Nikola Tesla up from the great beyond. You feel me? So Robert O. Becker, right? This is the guy. who's dealing with the regeneration of the human tissue and stuff like that. So Robert O. Becker, um, right? So building on the foundation laid by Szent-Györgyi's work, Robert O. Becker, a pioneering orthopedic surgeon, established the field of bioelectricity. He challenged the reductionist biochemical model of the body, arguing that a more holistic understanding required the inclusion of its electrical properties. Okay, Becker's groundbreaking research centered on the discovery of a direct current electrical system that he found to be fundamental to primitive restorative functions like growth and healing. One of Becker's most famous discoveries was the current of injury, an electrical signal, right, that appears at the wound site and initiates the healing process, right? An electrical signal that appears at the wound site that initiates the healing process. Through his experiments on amphibians like salamanders, in the previous video we went into that. We went into Dr. Jerry Tennett's book, and he has a whole section on that. He demonstrated that a specific negative electrical potential at an amputation site was responsible for triggering the regeneration of lost limbs, right? A negative electrical potential at an amputation site was responsible for triggering the regeneration of lost limbs. He's talking about in salamanders and things. He found that this current could cause a process called de-differentiation, where specialized cells. Okay, so this is an important point. This is this thing he's talking about, de-differentiation. De-differentiation, where specialized cells revert to a more primitive state, enabling them to reform into new tissues. So this was a big deal as far as the regeneration of tissues or whatever the case may be. You can manipulate this with electric fields. You're saying that in salamanders and lizards and things like that or whatever the case may be, they could, there's increased electrical activity at the site of something being regenerated on their body and stuff like that. In humans, this is a latent thing or whatever. So we have to create the electrical field artificially, but it can still be done as far as tissue being regenerated and all that. His research goes into all that. Becker hypothesized that living tissues, including nerve and bone, possess semiconductor properties, a concept that had been postulated for some time. He demonstrated that bone is piezoelectric. We said that in the previous video. Let's see here. Becker's work suggests that body operates on a field-based control system. The current of injury is a macroscopic system-wide electrical phenomenon, a form of field-based communication. Field-based communication. So this is on a macro scale. Um, Cells are doing this. Um, Remember, we always say from an experiential perspective, nature is self-similar across scale. We describe this from a perspective of the relationships between people. When we were talking about the morphogenic field, and on the more high side, the more super macro side, you see what I'm saying? Now we're talking about how cells communicate. No coincidence, cells communicate via fields and electricity, electrical current. Remember, we said the relationship between people and the fluctuations in in those relationships kind of mirror the pressure gradients across electromagnetic fields. We kind of made that correlation, but neither here nor there. Okay, a form of field-based communication that governs cellular behavior in a more direct way than a purely local chemical cascade. This concept of an invisible system-wide medium, the bioelectric field, that governs and structures more observable phenomena, cells and tissues, is a direct parallel to the etheric framework of Tesla and Dollar, which we're going to get into in a little bit. Both models propose a non-material layer of reality that is the primary. Both models propose a non-material layer of reality that is the primary source of form and function. So that goes right back to what Eileen Day McCusick was talking about. She was talking about harmonic resonance or acoustic resonance, how